Well, hello guys. I'm back with one more of your problems from worksheet 38. Let's talk about problem number 15. And there are a few very important points that I want to discuss in this situation. Let's read it first. A block of unknown mass is given a push up a 40-degree inclined plane and then released. It continues to move up the plane in the positive direction at an acceleration of negative 9 meters per second squared. What is the coefficient of kinetic friction? So the first thing to take into consideration is that what you really want to know as your final answer is the coefficient of kinetic friction, mu k. Now, in order to do that, of course, you need to do a problem with forces, which means that you definitely need a free body diagram, and that free body diagram needs to be rotated. Now they tell you that the angle of the inclined plane is 40 degrees, therefore your x-axis is 40 degrees with the horizontal, the y-axis is 40 degrees with the vertical. A short analysis of the most common forces tells you that you have a gravitational force Fg. You don't know the mass, so you cannot get it yet. And because this is a surface and it is supporting the object, you have a normal force Fn. But now the situation becomes a little more complicated, because they tell you that they gave this object a push at the beginning of the problem, and that push certainly gave it a velocity up the plane. However, that velocity is not consistent with the acceleration of the object once the object is no longer being pushed. When the push is removed, they tell you that it's still moving up the plane because it has an initial velocity, but its acceleration is in the negative direction. So your initial velocity and your acceleration are opposite. The obvious conclusion of that is that the object is decelerating, that it is slowing down. But when you talk about the forces, then given that there is a friction, you need to decide whether the friction is up the plane or down the plane. And the one thing that you have to take into consideration is that the direction of friction depends on the direction of motion, not the direction of acceleration. The object is moving up the plane, therefore your acceleration is down the plane. Your friction, is down the plane. And so you have a force of friction over there, and the components of your gravitational force are along the y-axis here, Fgy, and parallel to the x-axis here, Fgx. And of course, this angle is 40 degrees. Now, taking those ideas and keeping them in mind, you see that Newton's laws are applied as follows. The sum of forces in the x direction is equal to mass times acceleration, because if you guide yourself by your free body diagram, the acceleration is in the x-axis, and so it is the sum of forces in the x-axis that are equal to the mass times acceleration. There is no acceleration in the y-axis, so your sum of forces in the y direction must be 0. Now you have taken that positive for this problem is in the up the plane direction, negative down the plane, and so the two forces that are in the x direction are both negative. So when you separate this, what you have is that the negative of the x component of the weight minus the friction force is equal to mass times acceleration. And on the other hand, the normal force, which is in the positive y direction, minus the y component of the weight is equal to 0. Then you can start working a little bit of your algebra. The x component of the weight is Fg times the sine of the angle, simply because, as you can see from your triangle, the x component is the opposite to the angle, and opposite leg is sine, minus mu k times the normal force, and that's equal to mass times acceleration. On the other hand, your normal force is equal to your weight times the cosine of the angle. Reciprocally, you can see in your free body diagram that the y component is equal to the adjacent leg, and so cosine. If you substitute over here, and you substitute the gravitational force by mg, what you have is minus mg sine of the angle minus mu k mg cosine of the angle is equal to the mass times acceleration. Now, clearly, your acceleration doesn't depend on the value of the mass, because you can divide the whole equation by mass and everything cancels. And so, given that your unknown is mu k, you can simply play with the algebra here. Negative g sine of the angle minus a is equal to mu k cosine, g cosine of the angle, and so your coefficient mu k is equal to minus g sine of the angle minus a divided by g cosine of the angle. Making the proper substitutions, that turns into negative 9.80 meters per second squared sine of 40 degrees. Now careful with this, you have a double negative, minus negative 9 meters per second squared, all of it divided by 9.80 meters per second squared cosine of 40 degrees, and you can plug that in into a calculator, and the final result is 0.360. Notice, of course, that the dimensions cancel each other out, and that's only natural because the coefficient of kinetic friction doesn't have any units. It is an a-dimensional quantity. So, what are the important things to notice for this free body diagram? First, you don't take into consideration any upward push, simply because this object is not being pushed when it has this acceleration. It says released, and it says that it then continues to move up with a negative acceleration. So the negative forces are the ones that are causing a negative acceleration. You don't need an upward push. And secondly, remember all the time that the friction is directly related to the direction of the velocity, not the direction of acceleration. Because the object is moving upward, even if it is decelerating, the friction is downward. So that is your problem 15. Thank you.